Okay, so as always, we're going to slowly work our way through question 2 here and look at the examiner's report as we go. So let's begin. A drug X comes in 500 milligram tablets. The amount B of drug X in the bloodstream in milligrams T hours after one tablet is consumed is given by the function this right here. The very first thing that we need to do is find the time in hours it takes for drug X to reach a maximum amount in the bloodstream after one tablet is consumed. Express your answer in the form this, where A and C are real numbers. Okay, so let's begin. Let's come over here. And the very first thing that we're going to do is define this. Now, this is pretty ugly. And I think most people would be a little scared of this question purely because this is ugly. But do not fear, it's not that tricky of a question. All right, so we're going to come here. We're going to bring that up. 400.7. Then we're going to open our brackets. And then we're going to go this. And then, you know what I'm going to do? I'm going to bring up another one of these signs. Minus t over 5. Then I'm going to subtract this. Control that, negative 9t over 10, and then I'm going to close my brackets. Double check that that's all written out correctly. That looks good. I'm now going to do that. Now that I have defined that, the next thing that I'm going to do is a bit of optimization. So I'm going to grab my pen and I'm going to go solve the derivative of this when it's set equal to 0. Solve this for t, and that's going to enable us to find our maximum value, so finding where that stationary point is occurring. So having done that, I'm now going to go menu, algebra, solve, and then I'm going to go shift minus. I'm differentiating with respect to t, then I'm going to put b of t here. Then I'm going to set it equal to 0 and I'm solving for t, and then I'm going to close that off, and that is going to give me the value at which the maximum is occurring at. So that will be the time. And you might be thinking to yourself, well, how do we know this is a maximum? Can it be a minimum? Or you might be thinking all of that. If you wanted to double check, I think the quickest way for you to do so is to graph it. But just so you know, this is my final answer. So let's just write down what it is. So I'm going to say that t is equal to, and this could be written as 10 over 7 log e 9 on 2. All right, and if you wanted to double check that this is a maximum, you can graph this thing. So control doc, add a graph. We're going to graph b of x like so. Now, it's not going to be correctly, the window is not going to be correct. And the best way for you to figure out what the window should look like is to come down here, in which I've actually graphed it for you. And you can see that I should be going up to about 400. So 400 here. And then here I should go to about 6. So come here, let's go 6 there. And then I can move this across a bit. And there we go. So we have at the first thing right here, we needed to find the maximum. So menu, analyze graph, maximum from here to here. And as you can see, it's the time the maximum occurs is 2.15. And if I was to take this right here and get the approximate of that, it's going to be 2.1 round up 5. But remember, we don't want the decimals. We want it in this form right here. And this is what we want. Let's now look at the examiner's report to see how people went with this question. And as you can see, 73% of people got the full 1 mark. We have the working out here of the derivative, setting it equal to 0, solving it for t, and finding out that t is equal to this. That is correct. Oh, and they have put hours at the end of this. So let's do that as well, hours. This question was answered well. An exact answer was required. Some students converted t equals 2.15, all right, to hours to t hours and 15 minutes. So what that means is they didn't read this last bit in which it tells you how you should express your answer. You didn't have to express your answer, or you should not have, let me rephrase that. You should not have expressed your answer like this. You had to do it the way they told you to do it. And it is going to look like this. Notice that it is a 2 marker, so you had to show some working out as well. Okay, let's keep on moving now. The next thing that we have to do here. Okay, so it tells us that and look at this, this is a bit too big. Let's just minimize that. The graph of y equals b of t is shown here from 0 to 6. So here it is. So the amount of drug and the time in hours, find let me get my highlighter out, the average rate of change of the amount of drug X in the bloodstream in milligrams per hours. So it's telling us the units that we're dealing with over the interval 2 to 6. Give your answer correct to 1 decimal place. So 1 decimal place. All right, so what that means is we're going from 2 to 6. We're finding the average rate of change from 2 to 6. So from here to here, we're finding the average rate of change. And as you remember, that's simply saying that we're finding the gradient of this line. That is my average rate of change. If I can draw this line, it doesn't want to work with me. It's going to be just the gradient of that line. And to do that, we simply use rise over run, y2 minus y1 over x2 minus x1. So in this instance, we would come down here and I'm going to grab a black and I'm going to go average rate of change is going to be equal to, now, b of 6 minus b of 2 over 6 minus 2. Now this is a 2-mark question, so we do have to provide some working here. So let's scroll down here and let's put that in. So control divide, and then I'm going to go b of 6 minus b of 2, and then 6 minus 2 down here. Now it says give your answer correct to 1 decimal place. So I'm going to go control equals, and I'm going to end up with negative 33.48. Now it says to 1 decimal place. So that means my answer is going to be negative 33.5 milligrams per hour. That is going to be my answer. All right, so let's now look here at what they wrote. So the examiner's report here says that 70% of students got the full 2 marks. The average rate of change equals B6 minus B2 over 6 minus 2, which is equal to negative 33.5 milligrams an hour. That is exactly what we have written here. Some students used the average value of the function. Others made substitution errors. A common incorrect answer was 33.5. So it was incorrect if you left out the units. A common incorrect answer was 33.5. Oh, sorry, no. They forgot the negative as well. Several students used the graph to approximate values rather than find B6 and B2. Some students found the average of the gradient at B2 and B6. Found the average gradient at B2 and B6. Okay, so just people making some silly mistakes there. All right, let's keep on going. Another 2-marker, and again, this is too big. Let's shrink that. Let's get my highlighter out and read this one, which says, find the average amount of drug X in the bloodstream in milligrams during the first 6 hours after 1 tablet is consumed. Give your answer correct to the nearest milligram. All right, so what this means is we're finding the average value, and this is just something that we know. So we know that the average value is going to be equal to, and if we were to think about this in a just general way, it's going to be b minus a over b a f of x dx. So that's just kind of what I've committed to memory, but now obviously we're dealing with b of t, so this is going to be dt. We know that it is for the first 6 hours, so that means from 0 to 6. So 6 is my biggest value, so 6 will go there, and 6 will go there, and 0 will be my lower value, so 0 there. 6 minus 0 is just 6, so that is what we're dealing with. That is our average value. So 1 over 6 divided by that integral right there, well, 1 over 6 times that integral right there, rather. So I'm going to go shift plus 0 bt 6, put a t there, come over here, go control divide 1 over 6, and I want this as approximate like that, and it says that I need to give it to the nearest milligram, so that means I'm going to round this up to 256, and it's in milligrams, so mg. Let's now look at the examiner's report. right here. So as you can see, 56% of students got the full 2 marks here. The average amount of drug, so I wrote the average value. Let's just use exact language here. So average amount of drug equals 1/6, 60, let's put brackets around this, equals dt equals 256, nearest the integer. Some students used the interval 2, 6 from question 2c instead of 0, 6. Others did not divide by 6, which gave them this. This right here was often given. So, okay, that was taking each individual point, 0, 1, 2, 6, and then dividing it by 6. Okay. Some thought that the first 6 hours meant T1 to T6 instead of T0 to T6. Others evaluated this or found the average rate of change. Okay, so with that being said, remember 2 marker, show some working, and then give your answer. Next one, 6, and let me get my highlighter. It says 6 hours after one 500 milligram tablet of drug X is consumed, a second identical tablet is consumed. The amount of drug X in the bloodstream for each tablet consumed independently is shown in the graph below. The first thing that we need to do, on the graph above, sketch the total amount of drug X in the bloodstream during the first 12 hours after tablet 1 is consumed. Now, to answer this question, there are 2 ways we could approach it. We can use our CAS, or we could just do addition of ordinances to kind of roughly give this a sketch. What we definitely know is that we're sketching, so on the sketch the total amount of drug X. Okay, so the very first thing that I would want to do that we can kind of just immediately recognize is that for the first 6 hours, the total amount of drugs in the body is simply going to be this first wave right here. And then this is going to stop at t is equal to 6 because that's when they start, that's when they consume the second tablet. Now we could use addition of ordinances as we go on. So for instance here, we could take this point and we could take this point and we could add them together and it's going to take us to somewhere up here. We could take this point and this point, we could add them together, which is going to take us somewhere up here. We could take this point and this point, which when we add them together is going to take us somewhere near here. And you could just keep on going until you have your graph, which is going to look something like that. The other way to approach this, and the way I think I would do this in the exam, is to use my CAS to kind of do it as accurately as possible. So what I know that I'm doing here is I'm taking B of t and I'm plussing onto B of t this second consumption of the tablet. And it's exactly the same wave, just shifted 6 to the right. So that means I would come over here and I'm going to say, let's define the total amount of drug in the bloodstream as being equal to, and actually, sorry, let's call it the total amount. So BT of T, so that's the total amount, is going to be equal to the first tablet plussed together with, and this is where I'm going to write B of T minus 6. So that is the second wave. So just the same thing, just shifted 6 to the right. And when I do that, I'm going to get that. Now that I've done that, I could go, well, let's just graph this so we know what we're looking at here. I always find graphing things to be useful. So B of T of X is going to look like this. And let me just change this to 400, like that. It's going to look like this. And if you remember, my other one just disappeared there. Let's graph that as well. That is my first wave, that is my second wave. All right, so now I need some points. So I know that when B of T is equal to 6, it's simply going to be at this point right here. So like 100 and I need to go Control Enter, 190, good. What happens when it is 7? And remember, Control Enter to get that. It's going to be 422. So 422 would take me somewhere around here. Whoops, did that come out? 422. So I'm taking that point, adding them together, which is getting me there. Then I will go to B88. So BT8, Control Enter, 453. So 8 is going to be 453. So it's going to be around here. And you know what I would also want to find here? I would want to find where my maximum is. To find my maximum, I could just come here, go analyze graph, go maximum of the red one from here to here. The maximum is going to occur at 7.78. So that means the maximum is going to be around here. That's where the maximum is going to occur. And then it's going to drop down to there. And we keep on going. So let's go to 9 now. Whoops. BT of 9, control enter, is going to be 415. So BT 415, it's going to be somewhere here, is it not? This is a funky looking graph right here. There. It's going to be a bit further across to there. So try to be as neat as you possibly can here. This is not as neat as I was hoping it was going to be, and this is taking me some time. So maybe the addition of ordinances would have been a lot quicker than doing it this way, because I'm fluffing about 358, 10, 358. It's going to be about here. And then if I was just to kind of guess the next ones, I want to do it properly. It's going to be BT of 11. I keep doing that. I forget to hit control enter. 300. BT of 11 is going to be about 300. It's a bit more, but basically going to be there. And then last but not least, BT of 12. Don't forget to go control 249. So 249 is going to be about halfway. So that means it's going to go up. Whoa, that is ugly. Sometimes if you've got too many dots, it's hard, but it's going to look something like that. Please make yours neater than mine. But I think that should be acceptable. Let's look at the examiner's report and see what they've drawn. And of course, you should be replicating the examiner's report more so than what I'm drawing here, especially with graphs where it's tricky to draw stuff. I'm looking at it. There are some instances where I probably would want to fix it up a little bit. All right. That's reasonable, I think. So 35% of students got the full 2 marks here. Many students were able to trace over the first part of the graph from t is equal to 0 to t is equal to 6. So that part is obvious, the fact that because I've only consumed 1 tablet, obviously the amount in the blood is simply going to be that part right here. It's as soon as you've taken another tablet at t equals 6 that you're going to have that addition of ordinances there. Some students did not join the 2 sections at x is equal to 6, some starting at the intersection of the 2 graphs. So many people incorrectly just went like that, and then perhaps from here, then they started to go up, not realizing that you're taking the drug at this point right here, not at the intersection point. That's what that's referring to. Students could use the addition of ordinances or define this and use technology to sketch. So we did the second option there, but it would have been legitimate for you to do the addition of ordinances, as I showed you as well. So this is saying they use technology to sketch the graph and find the position of the turning point. Some students shaded the area under the graph. Okay, I'm not quite sure why they did that. Let's keep on going. Very last question here, which says, find the maximum amount of drug X in the bloodstream in the first 12 hours and the time at which the maximum occurs. Give your answer correct to 2 decimals. So similar to question 1 of this 2018 exam 2, this very last question of question 2 kind of comes back to what we were doing at the very start of it. So remember, this is similar to what we did at the start. We did the maximum, and this is what we used to do it. So now we're going to do something very similar here. So let's grab a pen and let's do that. So what I'm going to do here is I'm going to say that the B total here is going to be equal to, so B total of T is going to be B of T, B of T plus B T minus 6. That's what we know. And now I'm going to solve for when BT, so the total of it, the derivative is equal to 0 for T. That's what I'm going to do. And if I was to do that now, I'm going to go solve that, shift minus T, this B of T equals 0. No, that's going to be on the outside. Equals 0 of t, just like that. Do that. Wow. What did it say to give my answer as? 2 decimals. Thank goodness. I did not want to write that out. So control this. It's going to be 2 equals 7.79. Now it's 2 decimals. So that means t is going to be equal to 7.78 hours. So it says, this is where we have to read the questions carefully. It says the time, so find the maximum amount of drug X in the bloodstream in the first 12 hours and the time. So we've found the time, and now we need to find the max amount in the bloodstream. To do this, we're going to go BT of 7.78. Now, you should not use the rounded version of it when you're doing it. So we've rounded this. You need to use this one right here. So that means what I'm going to do is going to go BT of this right here, close the brackets, and then control enter. It's going to give me 455.816. Remember, 2 decimal places. So this means I'm going to get 455.82, and this should be milligrams. All right, so just to really highlight this, I'm going to use a highlighter. That's 1 and that's 2. So this is a 2 marker. So I imagine that because I've asked for 2 things, those are where the 2 marks are coming from. Yes, I imagine. Let's read the examiner's report. That's what you should be taking with absolute seriousness. All right, so only 19% of people got the full 2 marks here. So it says the total amount of drug is equal to BT plus B2. The maximum amount of drug is 455.82 milligrams, which we have there. And T is equal to 7.78 hours here, correct to 2 decimal place. This question was not well answered. Many students were unable to find a new rule and solved simply the derivative of B there. For T, getting 3 to 4.34 milligrams for the maximum amount of the drug. Some then added 6 to this answer. Some assumed that T equals 6. Answers were required to 2 decimal places. Other students gave only 1 answer. So really making sure that you're reading through the question and knowing what they're asking of you. But overall, this was a reasonable question. I think what made it seem difficult is that it's very ugly. So don't be afraid of things that look like that. Read the question, figure out what it's asking of you, and don't be thrown if things aren't pretty. Okay, so with that being said, that's everything. I'll see you in the next one.